For continuous air and water barriers on your next build, choose Zip System Ceiling Solutions. Seal tough jobs in a flash.
Welcome to the UnBuild It podcast. I'm Jake Bruton. Today I'm joined by Steve Basic and Peter Yost. Say
Potty
hello.
Pete.
Potty Pete.
Hello.
And today we are going to do another Q&A session here.
Great.
Unfortunately, we didn't bring the questions. We just brought the no. Isn't that what we said last time? Let's bring the answers and see if somebody else can come up with the questions. So, do we want to just jump right in? Or do we have any banter? Did we already get the banter out of the way with the conversation we already had?
Bantered out.
You're bantered out, huh?
I can probably always find more.
I just want to say I like the Q&A because we get to, sort of be a bit more spontaneous. Although, really, do we need to be a bit more spontaneous than we currently are? I think the Q&A are fun.
I hate the Q&A.
Okay.
But then again, I hate everything. So
Well, you're going to participate either way, though, right?
Exactly.
Okay. So let's start with a question from Michael. And Michael, I'm guessing, is a new listener because he's referencing episode 15. And I think we're into the 60s or 70s now. So Michael's, what is that? Halfway through year one of the podcast.
Maybe he's like just listening to him 7 times because that's what the science says.
I
7 times before you actually grasp the concept.
Interesting.
I'm following up on my question after listening to episode 15, in which Jake describes the monolithic slab-on-grade house he built for his parents in '99. Let's go back and recap for anybody who hasn't recently listened to episode 15. Excuse me. Maybe the thing you should do now is pause this, go back. But episode 15, in this conversation, we talked about insulation on the outside. We're talking about foundations. And we built a house for my parents, in 1999, traditional turn-down slab. So trench footing, 2x10 sitting on the ground after that, slab poured inside the 2x10. We took R10 or 2-inch XPS. We construction adhesived it to the outside of the foundation, and then we did brake metal on the outside of that, like you would use for bending around your soffit work or your fascia to cap it. And it looked really nice. White water table all the way down to grade all the way around the house. It looked really nice until the first time the guy that mowed the grass's son came to help him, and he weeded it up against the house and peeled pieces back and whatnot. But when my parents went to sell that house in 2016, the inspector said, I cannot give you an inspection on the foundation if it's covered up. So all that has to come off.
Whoa.
And my dad was just like, all right, screw it. I don't care. I want to sell the house. I'll take all that off there, thinking like, you're ruining it. It's going to be cold now and all this. We peeled it off, and it was like 60 to 70% gone. The foam had been eaten away by bugs and moved out of the way by rodents and snake skins, and like it had not been a good assembly. And for me, it was one of those moments where I was like, yeah, we definitely should not be putting stuff outside that's hard to protect.
So it's like insulation as habitat.
Yeah. And it just became a community, if you will. And so that's what he's referencing here is that conversation about I wouldn't do it that way again. I've thought about it again since then, and I still don't think I would do it that way. I'm not sure if I can come up with a way where I would feel like it is full-time protected for good. So his question is, I understand what you constructed was very similar to the assembly detailed below. He gives us a picture, which is basically the same thing I just described. And he says, does that mean that you feel a monolithic slab-on-grade should not be insulated at the slab edge with rigid insulation and sheet metal? That's a very simple one. I'm going to say no, but I want to hear what you guys have to say, and then I thought we would talk about the way that you and I have done it a couple times and some resolutions that we have.
So
Pete raised his hand for those of you that are just listening.
So first of all, if the two problems were the destruction of the protective covering and the destruction of the insulation underneath, could you pick a rigid insulation, for instance, rigid mineral wool that would resist being habitat, or could you pick a better or a different cover board? And it's not a rhetorical question. I'm asking that.
So certainly, I think by adhering rigid mineral wool to the outside, you still have some voids, some space, some access. Certainly not the same access that you would with an XPS that can just be eaten up by little things. There's always going to be some void between the concrete and the mineral wool. Or there's always going to be some gaps between sheets and things like that. So it's not a perfect world, but none of what we're doing is.
But, can we find a protective covering material that looks nice more than the first day?
Parch coat or something that...
Well, and I've done parch coats that get beat to crap by weed whackers. So, Steve, do you know of a...
Yep, I do.
I know what he's going to say.
Enlighten us.
Don't put it on the outside?
Well, no, I wouldn't. I would never put it on the outside, but there are companies that make
decent coverboard.
Well, the parch coat would be like a reinforced mesh that you can't get through with an axe. So there's systems out there. The question is they all cost money. You're working in not the hardest place. It's not like you're working overhead, but going around 300, 400 linear feet of surface at your ankles is a pain in the neck.
And at entryways?
And then you have all the entryways, decks, garage door interfaces.
Yeah, those
all these places that you have to interact with. Now, the garage door interface is one that, maybe you don't get there, but someplace the garage wall is going to intersect the house.
Yep.
And what do you do there? Just stop and take the penalty?
Yep.
Or or do you put this foam in? I mean, there's some pre-planning there that goes. It's the same adage that we always talk about, that if it's properly planned for and the right selections, you could probably make it successful. I think it's a challenge.
What about the planar issue? Like if you have that 2 inches of insulation on the outside, then you're trying to line it up with the wall above. Is that also something you have to overcome as you go along?
Well, I think the way Jake explained it, doing the trench footing and then the 2x10 on the top, you're going to have some kind of shelf and displacement there. So that's going to be a total pain in the ass.
Yep.
It's you need a stem wall.
Yeah.
Right. So you're changing, you're losing the efficiency of that trench footing.
Right.
To gain a nice planar surface to then install this on. But you could do something like maybe the 2x10 goes to a 2x12, goes down a little deeper. You spray the outside with closed cell foam or something. I don't know. But then rodents and stuff are just going to chew and get in there. So there's really,
So what we're saying, I think, all three of us agree, is that it can be done.
It's not our preference.
But it's not our preference by a long shot.
So I have one easy solution for all this. Really thick carpet pad and really good carpet. And just pretend that the floor is not cold and just live on carpet because it feels warmer.
It's still a challenge.
Yeah.
I mean, my original house, before I insulated the top of it, was like we had a nice thick carpet and stuff. There was a noticeable, very easily noticed difference when you walked within 2 feet of the exterior wall in February.
Yeah.
It was cold.
So Jake and I were talking about this because how much, if at all, that you need to insulate that slabbage is pretty climate dependent. I was talking to Coda about this a long time ago in Atlanta, I think, which is climate zone 3, that he thought approximately that the energy penalty for not insulating the slabbage in Atlanta was around a 10% very rough 10% penalty. Well, that means if you go to climates warmer than that, it becomes less of a thermal comfort issue and less of an energy problem. But you go up to climate zone 5, which you were describing for your house, now all of a sudden, that in terms of thermal comfort, condensation in the carpet and the covering underneath, all those things just become way more problematic.
I've had a lot of people, in like climate zones 5 and above that just say, in the wintertime, you can't walk around the outside of the house. Yeah. It is freezing cold.
Yep.
The floor.
And so let's talk solutions if we're going to bring it to the inside.
I always push the slab outside of the house, and my latest details insulate on top of the slab. It is the least amount of insulation that you need to buy. It is fully continuous, but
So you're saying pour the exact same assembly that we poured for that house in 99, footing with a slab sitting on top of it. All of your regular MEP stuff comes through it the way it normally would, your water lines, your sewer lines and everything. And then you're saying, let's use that as our building platform, and we'll put insulation on top of that.
Yes. And the beauty is you can climate tune the level of insulation to where you are. So if you're in Atlanta,
kind of like a slider detail for slabs.
So if you're in Atlanta, maybe you only put an inch or inch and a half of Subterra or something on top. If you're in Minneapolis, you put 4 inches of EPS on that floor.
And so
you're pushing the concrete slab outside.
Pushing the concrete slab thermally outside of the building. And you can maintain 100% continuity.
Yep. Yeah, because you can get one solid
except for bearing points, but I'll give up 4 or 5 point loads that are 6 inches square.
Yeah, or the stuff that you and I are building that aren't ridiculously scaled. I don't think we've done one yet that had a bearing.
No, we just flew from outside wall to outside wall.
So one quick caveat, which is if you're doing a radiant floor slab heating system, now rather than pushing the slab out, we need to pull it in. And we can do that, right? You either pull the slab all the way in or you push it all the way out.
But even if I did that, I would do something like warm board. And when I do the insulation, I do 2 layers of 3/4 inch plywood. So I would just, or Advantech, I would take off the top layer of Advantech and substitute it with warm board's S panel,
so you're
which
saying
is 1 1/8 inches.
Not pour the radiant floor system in a topping slab or the concrete. Create another venue for the.
Well, I do that venue anyway.
Yeah,
you do that venue anyway.
Yeah,
which I bet there's better efficiency out of that because the warm board takes a lot less to heat up than it would to be heating a slab, even if the slab was inside the envelope.
And if you have warmed concrete. Now your delta T from indoors and out is even greater, and you're going to have to put in a way more insulation, particularly in a cold climate.
I'm working with them on some stuff, and we're going to be doing a house with a system. You're going to be excited. Their engineers are telling me it is the most efficient way to heat water for a heating system out there, the one they're coming out with. So
air to water?
I can't talk about it.
Okay.
He is talking about it, but he can't talk about it.
Yeah, I'm talking about it.
And since he doesn't really drink much alcohol, we can't use that. We can't apply him.
Yeah. I also think while we're on the subject of like that, there's a couple things with the insulation on top of the slab and then subfloor. Number one, you have to select an insulation that is going to carry the load. You can't just put anything down there. So you need to have your engineer involved.
Yes, that is true, but it isn't true.
It is a small load. Because
if you took the crappiest piece of foam, what's 20 times 144?
Okay. He's making a square footage PSI. Yeah.
Well, I'm doing a PSF. Yeah. But it comes out to 900 pounds per square foot or something with even a 20 PSI rigid foam. So don't come at me with that anymore because it's a dumb calculation. I'm not saying you don't come. I'm just saying people, because the minute
he is calling me dumb though.
The minute we put that up on social media, people say, what kind of foam is that? Isn't the foam going to crush? No, even at 20 PSI, it's like 900 PSF. Yeah. It's extremely strong.
Although there are grades of EPS that are far below 20 PSI. Yeah. So it's not like you can use any EPS.
Do 5 PSI. You're still at 600 or 700 pounds per square foot.
Yeah, but that stuff just crumbles all over the place. There's other
you think it does, but it doesn't because you have an inch and a half.
It's just
you have an inch and a half raft that's floating on it that's applying a uniform load. It's going to be...
It's the conversation that we have when people look at the preformed Schluter pans that we use that are pre-sloped for shower bases. Mm-hmm. They're 300 PSI.
Wow.
Or they're 300 pounds per square foot.
What's a fiberglass tub? It's not 1,000 PSI.
Porcelain
I've stepped in fiberglass tubs and heard them crack under my feet. And I'm only 200 pounds.
Yeah. Got it.
But even if I stand on two layers, of Advantech, my 200 pounds doesn't go into that 1 square foot.
Right.
It probably goes into about 20 square feet.
Yeah.
In reality.
Yeah.
So 10 pounds a square foot is what I'm exerting.
We also
that
should
floor
say,
system.
full disclosure, the assembly that we're talking about is normally with us 2 layers of Advantech that are glued and screwed, and Huber helped us come up with a fastening
It's a
schedule.
giant raft.
Yeah.
And they sponsor Home Building Crossroads, which all 3 of us speak for Home Building Crossroads in the podcast. So you're welcome for designing an assembly with 2 layers of subfloor.
I helped. I worked with their marketing department on that.
Yeah, exactly.
It's like, why sell one house of floor sheathing when we could just sell 2? But it works really well. I did that system on my house as a retrofit. It's a great retrofit system too.
Yep.
Okay. Next, we have we're calling that answered, right?
Yeah.
If you wanted to bring the slab inside,
I was pretty much done when you said, let's get started, but go ahead.
Sorry, I did skip one of the 2 things that we just talked about, Peter. The other way that you could do that if you really wanted concrete floors is you could do a stem wall on the outside with a reverse brick ledge so that you could do a vertical leg of insulation on the inside of that stem wall, insulate on the top of your aggregate, pour the slab inside of it. So in other words, your slab becomes that floating layer of subfloor that we're talking about.
I got 6,000 homes in the Southwest with that detail.
Yeah.
Any
was
problems with
homes.
where the exterior wall lines up with the insulation?
No, because we always made it work.
Yeah.
You have to be
Pretty
you have to
intentional.
understand where that inside face of the foam is so that when the drywall and the base molding comes down, it's covering that joint.
Can we all agree that one approach to solving that is not to put a 45-degree miter in the vertical leg of the
Yeah,
insulation?
let's not do that.
Holy smokes.
Yeah,
That's
we won't
just
do that.
crazy.
So the first time that we did that assembly, we definitely ended up adding base shoe to a house that didn't need base shoe.
It's
Aesthetically.
You bring up that detail because I'm in a cranky mood this morning. It's amazing to me that like we just chase these details and do the dumbest things. I see so many details out there that get posted and stuff. And some of them are even in like magazines or on websites. And I sit there and go, I would never do that. Why? Just make that brick shelf an inch bigger. Make the foundation wall an inch wider or something. People say, oh, that costs more money. Okay, it does. But doing the right thing costs a certain amount of money to get the system right.
Yep.
Buying 2x6s instead of 2x4s for the walls also costs money.
Yeah, exactly.
Okay, when designing to mitigate moisture, this is from Brennan.
Hello, Brennan.
Thank you.
Do we know where Brennan's from?
Virginia. What did we say?
The big VA.
We looked it up. It was
Richmond, I thought.
Yeah.
Richmond, Virginia.
Oh,
So
okay.
climate zone 4A.
Yeah.
We got
because we had a
other
climate
friends there.
zone.
What's those guys' names?
Uh,
Haynes?
Tom Haynes. Yeah.
Yeah. Hello, Tom.
High performance builder in
I'm sure he
Richmond.
listens.
Great guy.
When designing to mitigate moisture buildup at the ridge of a conditioned attic, is the general consensus that it is enough to utilize the mechanical system coupled with a dehumidifier to manage the moisture from the house, or would it be best practice to design some sort of ridge with a semi-permeable vapor open membrane over the ridge?
So we're talking about an unvented roof assembly where the insulation and the air control air are at the rafters.
Yep.
Okay.
And moisture migration at the ridge or through the whole assembly, which leads to the ridge eventually.
Right. So the first response is you have just designed a cathedralized attic, and the definition of cathedralized attic is it's not a cathedral ceiling where people are looking up at it. It's a dedicated space, but it's not living space. It's mainly for the mechanical systems. So when you look around, you're looking at probably the insulation and the air sealing materials. The code, the most current energy code requires that you do something to move that air in that assembly so that moisture does not accumulate at the ridge.
In other words, you're supplying something into there. And
You can dehumidify it, or you can simply supply conditioned air to that space at 50 CFM per 1,000 square feet of floor area. That's what the code says. And I
That's
believe
a weird calculation that they use floor area and not
well,
volume, because that's a wildly different number for.
I'm not quite sure why we use floor area, but it's interesting that we use that for crawl spaces too, that you have to move 50 CFM through 1,000 square feet. But anyway, just move the air. Don't allow the moisture to accumulate at the ridge. Now, the idea of a vapor permeable ridge detail, now everyone in climate zones 1 through 3 should go look at the details on buildingscience.com resources for vapor diffusion ports. And those are specifically to address air permeable unvented roof assemblies with cellulose insulation because it's less expensive, or some people choose it for its environmental profile. And Joe and his crew at Building Science Corporation have shown through their testing that at climate zone 3 and below, you can put in a highly vapor permeable air sealed cap, and you'll get enough moisture migration out through that cap to keep that assembly safe and dry. Joe has tried to push this to colder climates, and I think the research is still ongoing, but the word that I hear, and you guys can check on this when you go to Building Science Summer Camp in a couple of weeks, that too much moisture, you can't move enough moisture through that vapor diffusion port when you get to climate zones 4 and above. So the answer is you would have to, per the code, in an unvented assembly like that, use an air impermeable cavity insulation, not a air permeable
In
cavity
conjunction
insulation.
with the vapor.
In conjunction with the vapor diffusion ports. And in the 2018 code and all above that, there's a section in the code R806.5, which is dealing with...
He doesn't have notes, by the way. He pulled that out of thin air.
No, I reference this so often because this comes up an awful
I'm
lot.
going to check it.
But in the very detailed sub-letters of unvented roof assemblies, it talks about when you can use diffusion points and under diffusion ports and under what conditions.
And so why the difference for climate zone 4, 5, and 6 at delta T?
My understanding of the research is that enough moisture moves up into that assembly and condenses that you can't make the vapor diffusion point at the ridge move enough vapor through it. Now, they picked pretty challenging conditions. My memory is that they chose 50% relative humidity for all of the space below the unvented roof assembly. So what would happen if you could guarantee that the wintertime relative humidity in that building was 30% rather than 50%? I bet you could
Something
move it
wildly
to
different.
work into climate zone 4 and 5.
That begs, if I was to answer this question, I would have backed the truck back up to the loading dock and said, before we even get into the attic and start designing it, be concerned with what level of moisture are you allowing to migrate to the attic.
Correct.
Right.
Yes.
So you're talking 50, 60 plus % relative humidity in the attic. And how do we deal with that? But Brennan, understand that dealing with that moisture load inside the house before it gets to the attic with proper ventilation and venting, then you can minimize that problem. You could even put like a Sega Myrex in the ceiling plane that just slows the amount of moisture that's going to migrate into the attic.
So you're right, except the code is very clear under what condition you can use that. And they do not mention smart vapor retarders as part of a strategy for using air permeable cavity
That's
insulation.
why I don't follow the code.
You heard it here first. Steve is not a code follower. Anyway, it's a great question, but there's great resources for this topic.
So one of the things that I was thinking about when you were describing all of this too is a conversation I've had with multiple people where they go, well, how can it be vapor open but airtight? And the first time somebody asked me that, I kind of stood there and was like, I'm not sure how I can describe that. And then I went, oh, wait, it's a piece of drywall.
Exactly.
Moisture can migrate through drywall without air moving through the same.
So how is that possible? Drywall half inch is 40 perms, right? That means that if we consider something vapor open, if it's more than 10 perms, this is 4 times more vapor permeable. But the standard for air tightness in the ASTM standard is half inch drywall.
Yep.
And so the answer to this question is air molecules are big compared to water molecules. And so if water is in the vapor form, you have a pretty tiny molecule of water vapor. and the oxygen and nitrogen molecules around it are much bigger. That's how you can get something that stops airflow but lets vapor through.
You know what I'm going to say? Just go up to that wall of drywall, pucker up, and put your lips on it and try and blow through it. Go ahead. We don't have to play science lab here.
Steve is into intimate field testing because he's puckering up as he approaches the wall.
Intimate field testing. I like it. Peter, I'm going to let you take the last question.
Okay, so the last question is something that comes up an awful lot for me in my work, looking at design and spec review with builders and architects, and that's what's the best practice for detailing the bottom edge of the structural sheathing where it meets or comes into contact with the concrete foundation system. And
I would say it overlaps the foundation.
so the first thing, Steve and I talk about this all the time, is a lot of builders like to have the outside edge of their exterior sheathing in the same plane as the outside edge of the foundation. So their exterior sheathing sits generally on the top edge of the slab.
In other words, your plate would be back from the
I
edge
have
of the
no idea what
concrete.
the benefit is for that.
They get to set it down on there when they're nailing it.
But what Steve and I
Yeah,
like
maybe.
is to
That's
have
it.
the framing, the outside edge of the framing line up with the outside edge of the foundation, and therefore the structural sheathing, regardless of how thick it is, it's stepped out of that plane, and actually we like to overlap it. So there's a little bit of a, when you set the wall, you kind of like pull it in back against the foundation. Now, you've now put a porous material in contact with another porous material. So there's the issue of separating those two. But more importantly, that bottom edge of the sheathing, even if it's zip, which has a great waterproof or a water-resistant layer of the polymer on the outside, green or red, that's the weather barrier, and the air control layer, you still have that exposed edge at the bottom. So how do you detail that to protect it? And Steve, I know you've got a couple of different systems for
Wait, hold on. So first of all, it should not be in contact with the concrete from a code perspective, because there should be a capillary break between it and the concrete, period.
Bingo. You need something
that's
to
number one.
Yes. You need something to separate those two porous materials.
Sorry, I thought that was pretty important, and we needed to cover
That's good. I mean, I'm kind of torn on it. We've done, like Sega's Fentrim tape, which has some permeability.
You said Fentrim tape.
Fentrim tape.
Which, by the way, is designed to adhere to clean concrete.
Yeah, if you wipe the concrete clean, that stuff will stick.
It's amazing.
You will not get it off. It's very aggressive. Part of me wants to just leave the OSB exposed to dry.
Mm-hmm.
So, but the problem is most of my projects, we use Zip R6, R9. So we have the foam that we have to block somehow.
to
protect it and to keep rodents and stuff from climbing up in there. And so I've done that a number of ways. I mean, we've done everything from like nice copper flashings under there to just, working with Jake and extending a treated plate out at the bottom, and then have the wall sit on it, and then have the plane come down flush, and then tape that.
So what Steve's describing there, just so we make sure everybody's following, we still chalk our lines as if we're going to use a 2x6 plate that we want relatively close to flush with the face of the concrete. And then we custom cut a bottom plate that is a 2x6 plus whatever zip R that we're using, so that when we frame our wall, we can lay our 2x6s flat. We have a bottom plate that we're laying flat when we're framing that sticks up the height of the zip R. When we stand it up, the zip R sits on that plate and it overhangs.
Got it. So you're protecting both the sort of the trailing edge of the sheeting and the polyiso.
Mm-hmm.
Yeah.
It also makes air sealing a little easier because we have an air seal under our plate at that point, and then all we have to do is tape from the face of the plate down to the treated. So at that point, then we can use a cheaper tape, a more cost-effective tape, like the zip seam tape, because we're just going to treated wood. Although I really do like the Fentrim, and the last project we went from that vertically to connect the two, horizontally underneath the treated plate and then down onto the concrete, and we eliminated the air seal underneath the plate then.
Huber has a detail for both Zip and their Zip R panel where there is a metal flashing at the bottom of the wall that gets head taped to close off the exposed edge of the metal flashing.
So it's like a little J channel.
It's a little J channel. It's to pull the water that comes down the plane of the sheathing, the weathers of the barrier, and kick it out away from, so it doesn't curl around back into the sheathing. And I think that's a really good detail. Some people say, oh, that's sort of overkill. There's a bit of a debate about the approach of taking a liquid flash of some sort and mucking the crap out of everything at the bottom edge as both a way of protecting it from getting wet and also to keep it air sealed where it meets the concrete. Steve, I've heard him say many times, I learned a lot from Steve, and he said, you should always be thinking about what you're sealing in as well as what you're sealing out. So if you use a material that is going to stress crack readily there, where it cracks, you're now going to be holding moisture in as opposed to keeping it out. So it's got to be a really high performance sealant or liquid flash in order to keep that joint closed.
I would make a process argument too in that instance because I really like liquids in most cases because of their workability, their monolithic nature. The problem is anything at that height is a crappy laying on the ground job. And trying to work with liquid when it's dripping and you're trying to keep it off the foundation so that nobody sees it. We've done it. We did it at the Prairie House. We used a liquid in that instance. And I ended up going around with a brush attached to my grinder, cleaning a bunch of liquid flash off, trying to,
Interesting.
So I'm not, it's harder to screw up a tape detail there than it is to screw up a liquid detail there. It's one of the places that I make an argument that we ought to just use the tape.
Interesting. Good.
Yeah.
What he said. Okay.
That's all we got.
That's it?
That's it for today's Q&A. 3 questions. That's all we got there.
Should I make up a question?
Sure.
No, we're good. We're at 30
You're going to ask me
minutes.
the meaning of life.
No.
I'm going to give you the City Slickers answer.
For one, I wouldn't go to you for that answer.
It's the one thing.
Remember, I'm the lotus flower.
That's
so
not
you can
cool.
come to me with these kind of questions.
I just laughed. That's not cool. I'm not supposed to laugh.
Okay, we're going to say thank you for listening today. Don't forget to subscribe to us on YouTube. There's content that publishes every day of the week, or not every day of the week, Tuesdays and Thursdays on our
scared
YouTube
the crap
channel.
out of me every day of the week.
Pete said, we have a YouTube channel?
What's YouTube?
YouTube.
Is that on the computer?
We tube. We all tube.
If you want to send us questions at UnBuild It Podcast. When we have time, we email a response right away. It doesn't always happen. Sometimes all of us have other jobs that keep us busy, and sometimes your questions just wind up here. So give us some patience when you send a question. It may take us a little while to answer it, but we do thank you for sending them in because the Q&As are one of my favorite.
We should let people know I do just-in-time delivery of answers, but it's expensive.
Yes. So if you really have some good Q&A questions, send them to Pete instead of to us. That's all for today. Thanks for listening.
Bye now.
Thanks, everybody.